Hello everyone. Today I'm going to discuss power, momentum and impulse. Let's start with power. This topic is related with last lecture's topics. In last lecture, I discussed about work done, kinetic energy, potential energy, work energy theorem and conservation of energy. Now the question is, what is power? Power is the rate at which work is done. So power is related with work done and work done is related with energy. More power means more work is done in the same amount of time, or the same amount of work is done in less time. For example, a person that is a more powerful runner is faster and can run further in the same amount of time as a less powerful runner. So basically more work is done in equal time. Another example, a car with a more powerful engine can accelerate to 60 meters per hour faster than a car with a less powerful engine. Basically, I can do mainly I can do more work in equal time. So it's represent if work done is more, okay, in same time, then power is also basically more. Now, how to calculate the power? Okay, the procedure how to calculate the power. So the power is measured in watts. So the unit, basically unit, not SI unit of the power is watts. So we need to know two things in order to measure the power. First one is the amount of work being done. Second one is the amount of time it takes to do the work. So you can say that basically power is depend on the work done and the time duration of the work. We can calculate power using the following formula. So here power is equal to work divided by time, which is P is equal to W by T. Here P represent the power, W represent the work done and T represent the time. So the units of the power is watts. So 1 watt equals a joule divided by 1 second. Now let's solve a particular problem. So if an engine does 100,000 joules of work in 10 seconds, how much power did it use? The formula to calculate the power is P equal to W by T, and here given value of the work done is 100,000 divided by 10. 10 is the particularly time, 10 seconds. Then the power is 10,000 watt. Okay. So this is basic formula P equal to W by T. If work done and time is given, you can easily calculate by using this formula. So the engine used 10,000 watts of power. Okay. Now let's just basically just see the another thing is here. So because work equals force multiplied by distance, another way to write the power formula is, so if we just related this power with force and distance, the formula is power is equal to force into distance divided by time. So basically the force into distance represent the work done. Okay, so P is equal to F cross D divided by T, then P is equal to W by T is same as P equal to F cross D divided by T. So if work done is given, we can easily calculate P equal to W by T, and if the force and displacement is given, we have to use P equal to F cross D divided by dt, or we have to just calculate work done first. Now let's solve problems related to these topics. So if an engine exerts 3,500 newtons of force to move a car 50 meters in 10 seconds, how much power did it use? The formula is P equal to F cross D divided by T. So here the force is given 3500 Newton and the displacement D is 50 meter and time is 10 seconds. So if you put the values, so P equal to 3500 into 50 divided by 10. So finally the answer is 17,500 watt. Okay, so the engine used 17,500 watts of power. Let's solve another problem. A car, sorry, a 1000 kg 1000 kg car accelerates from 0 to 100 kilometer per hour in 3.2 seconds on a level road. Find the average power of the car. So here mass of the object is given and also just velocity is given. Velocity is 0 to 100 kilometer per hour and the time interval is given 3.2 seconds. So here velocity, initial velocity is 0 and final velocity is given in kilometer per hour. So we need to convert it into meter per second, which is SI unit. So initial velocity is 0 and final velocity is 100 kilometer per hour is equal to 27.78 meter per second. Okay, so if we convert the kilometer, we need to just multiply 1000, and if we just convert hour into second, then we have to multiply 60 into 60. Okay, so finally final velocity is 27.78 meter per second and the time is given t equal to 3.2 second. Now here the another thing is here mass is given 500 kg. Now if we try to find out the power, so power is equal to W by T, and we know that according to the work energy theorem, work done is equal to change in energy, mainly change in kinetic energy. So here the thing is that the velocity is changed from particular value to another value. So that's why we have to use here the energy change is equal to work done. So half mv f square represents the final velocity, sorry, final kinetic energy, minus half mv naught square represents the initial kinetic energy. So final kinetic energy minus initial kinetic energy gives the work done. So this work done divided by T gives the power. So P is equal to half into 1000 into 227.78 square minus 0, since final velocity is 0, divided by 3.2 second. Okay, so finally the answer is 121,000 watt. Okay, so the power of the car, power of the car is given 121,000 watt.